So I think we can probably get started with the webinar since it's already 6 o'clock here in Riga. So let's get started. Some people, again, are probably still joining, but I think we can at least get some initial things out of the way and then move on to the main topic of the webinar. First of all, hi, everybody who has already joined. My name is Kristaps. I'm the product owner of UgCS, flight planning software. And in this webinar, I'll take you through some of the new features that we added recently, as well as, of course, show you the software demo of how these new features work. So typically, we don't really do webinars for new versions of UgCS, but since I think that for this one, there's quite a lot of interesting new changes, and it's important for you to also understand how certain algorithms can behave in certain situations. I think it's important that we also cover all of this, and plus, just give you an additional opportunity to ask any questions that you might have regarding UgCS. So I think that then we can probably get started. So at the very beginning, just a bit of housekeeping. The overall duration of the webinar, I plan that could be around 1 hour with the Q&A session included. So this will probably be a bit shorter than our typical webinars. So let's hope we also manage to save some time while also covering all the questions and all of the ground that we have today. After the webinar, you will also receive the recording. So all registered attendees will receive the full webinar recording. So in case you missed some parts or something, then you will be able to also rewatch it. During the webinar, so here in Zoom, as you know, so there's the chat section and the Q&A section. So chat section, please use in case you just want to tell us some general information, such as, thank you and so on. But for any questions that you have during the webinar about anything that I'm telling, or maybe even some general questions about UgCS, please put them in the Q&A section. So today I'm also joined by my colleagues, Alexandros, who is from our support team. So Alexander will be able to help with any technical questions. And also we're joined by Zana, who is our lead marketing person here at UgCS at SPH Engineering. So yeah, she'll also be able to help with any marketing questions if you will have them. The agenda today will be firstly the introduction to UgCS, the introduction overall about the webinar, as well as some general updates from our company side. Then we'll talk about the new features in UgCS 4.17. Then we'll move on to the software demo of the new features, and then move on to the questions and answers section. So any questions that will not get answered by text in the Q&A section, so these we will cover at the end. So many of them also I will try to answer live. So then let's maybe get started with some general news from our side. So recently we launched a new site for UgCS. Probably many of you still have not yet visited that, or maybe many of you already have. But so I maybe will jump on over to the site itself, just to show you basically where you can find certain things, since also, of course, things such as downloads and where to get support and other resources, I think it's important to know. So now still by entering ugcs.com in the browser, you will now get taken to the new site, which is here on sphengineering.com already. For all supported drones, so now we have a list of supported drones in a single place. So by clicking here on supported drones, you'll get taken down where you can see the list of different drones from different manufacturers which are supported in UgCS. One important note here that not all supported drones are on this list. So there are still other Autopilot and PX4 drones, which are listed here under Maveling compatible. So other drones will also work. Just because that drone you want to use is not on this list does not mean that it will not work. Only exception here would be for DJI. So all DJI drones which are supported, these are here in the list. So we do not support smaller DJI drones such as the Spark and Air2S and so on. That's just a note about supported drones. Next, when you need to download UgCS, or maybe you also want to read the release notes of the newest version. So this you can find here. If you go to downloads, then UgCS, and then when you get taken to the site, so here always you will see the newest version of UgCS as well as our Android app, UgCS for DJI. And then down here, you will always have the release notes where you can see what's new in each new version in UgCS. And by the way, starting from version 4.16, you will also get these release notes within the software itself. So that's about that. And here on the support section, there's a bunch of interesting and useful resources for both UgCS, UgCS Commander, and as well as Mapper. So here you have the manuals, different instructions on how to connect drones, video tutorials. From here also, you can access the link to go and purchase annual support and update packs, which are here on our shop. So yeah, that's about that. So I think now let's maybe move on back to the presentation here. Just wanted to do a bit of a side note about our new site before we get started with the features of 4.17. So, but now about the topic of the webinar. So now let's get started. So the three main features which were introduced in 4.17 are the following. So number one, we added support for the M350 drone. Next, we implemented a new terrain following mode, Smart AGL, and on this probably we'll put most of the focus on today's webinar. And then last but not least, we also implemented adjustable corner radius in all routes in UgCS. So let's kind of tackle these one by one, and I'll tell a bit about what has been done there exactly. So number one, about the DJI M350 drone. So if you saw before on our site, so this drone also now has been officially added to the list of drones supported in UgCS. From the software, what this means. So number one, the M350 drone profile has been added for route planning. So now it's available already within UgCS. You can plan routes for your M350 drone. All the payloads, they are transferred over from the M300. So all of the ones you had available for M300, they're also available for the M350. What's important to note here is that M350 can be connected to UgCS using the direct connection from DJI Pilot 2 to UgCS. When I show you the software, also I'll show you how this can be done exactly, although I'm sure many of you already know that. The process is quite simple, but still I think it's good to just kind of do a once over for that. A very important note is that the M350, this is supported only through connection from DJI Pilot 2 to UgCS. So it is not backwards compatible with UgCS for DJI Android app, which is working on the M300 drone. So to connect the M350, process is the same as for the Mavic 3 Enterprise series drones and the M30 drones. So you have to connect directly from DJI Pilot 2. One small note also here about the M300 drone. So since many of you might know that for the M300, it is now also possible to use the DJI RC Pro, I believe it's called. So basically the remote controller with the larger screen. If you use that remote controller with the M300 drone, you will also need to use the direct connection through Pilot 2 to UgCS. So on the DJI RC Pro controller, I'm really hoping I remember the model correctly, but in any case, it's the one with the larger screen that by default comes with the M30 drones. So this one also, even if you use it on the M300, in that case also you'll have to use direct connection from Pilot 2. You won't be able to use it with UgCS for DJI Android app. So that's just kind of for general information, and so you know what can you expect when you are connecting the M350 drone to UgCS. So I think this more or less covers this topic. And now let's move on to the Smart AGL, or the highlight of today's webinar. So here in the picture also, you can see what Smart AGL does and how is it different from the normal AGL. So one of the main things that make this algorithm different is the fact that, as you can see here on normal AGL, so the waypoints, they're basically always measured vertically with respect to the ground underneath the flight line. So on the normal AGL, it's not kind of looking, where is the terrain after that point where the waypoint is placed. Of course, it is checking, still how the ground elevation level moves, how it changes, but this still means that sometimes the flight line can be put a bit too close to the cliff. And this is especially important when you need to fly over some rugged terrain, when there's a lot of terrain elevation changes, or even when you need to fly up steep cliffs. So with AGL, I do not recommend trying to fly up steep cliffs. because most likely you will run into the drone's obstacle detection sensors, stopping the drone if it gets too close to the cliff, and that's the best case scenario. So AGL is not designed for that. But so Smart AGL, there's a different story. So with Smart AGL, what we implemented is the ability for the algorithm itself to measure or keep a constant distance to even surfaces which are further kind of ahead on the flight line. So this means that even when the drone is flying up a steep hill, so then GCS will understand, so what's the difference, what's the distance to that hill, and it will keep a constant altitude. So this means that even when you're flying, for instance, up or down vertical slopes, even then GCS will maintain a constant distance to those slopes. So it will make a lot more sense also when I show it to you in action. But yeah, so those are the main things. And plus, additionally, this also has some changes in the behavior of how the side movements between the survey lines work and how the overshoot segments work. So about these also, when we get to the software demo, about these also, I'll show you a bit more and tell you a bit more detailed information. Just a quick reminder, with any questions, make sure to leave them in the Q&A section. I'm sure about these you probably are wondering, maybe how does this work in certain scenarios and so on. So please put all the questions in the Q&A so we can answer them during the webinar. But so then moving further, so I just here added a bit of a screenshot where you can compare both algorithms. So I found a location where there's quite a steep cliff here. And so you can see on the left side, we have the normal AGL algorithm. So here you can see how close actually the flight line gets to the surface. So basically here also you can notice that all the waypoints, they are set at the same AGL altitude. So this means that as the drone gets closer and closer to the cliff, you can see how close the flight line gets there. And then moving on to what's here on the right side, so this is already the Smart AGL. So you can see that the Smart AGL algorithm, it figures out, so what's the actual distance to the vertical wall or to the vertical cliff in this case, and then it increases the altitude of the waypoints and also places them so that the drone is able to keep a constant distance to that. When I say constant, I mean, of course, more or less there is a deviation of some meters, but you can see how the drone is already at a safe distance from the cliff and how it is able to now fly up the cliff using the Smart AGL terrain following algorithm. So again, we will get to that in a bit more detail when we get to the software demo, but now I want to talk just about the third topic here, which is the adjustable corner radius. So up until now in GCS, we have had adjustable corner radius parameter only for the LiDAR tools, at least in GCS desktop. And also, however, in the mobile app, there has also been the possibility in GCS for DJI app to change the corner radius. However, there wasn't any visualization, and I think also a lot of people did not really know about that function. So now what has been changed? So with the integration of GCS with DJI Pilot 2, we understood that, hey, there's now a reason why we should have the ability to change corner radius, since it's also important for how adaptive bank turn works in DJI Pilot 2. So we added a new corner radius parameter in GCS, which is now available under all route parameters. So when you open up your route parameters window, that's where you will see it. I'll also demonstrate that in a moment. And also this corner radius parameter has also now been added to waypoint segments. So this means that even for individual waypoints, you're now able to adjust the corner radius. So how should the drone fly through these waypoints when using adaptive bank turn? Again, just want to emphasize this for now, this is supported for DJI drones only. So yeah, then the adaptive bank turn also is visualized actually. So in between these segments when you're flying, so as indicated here, this is a simple mission of only 3 waypoints. And so here you can see that actually GCS does display the radius of the curvature. So then, yeah, another thing I wanted to mention here is that the corner radius in the LiDAR tools, actually, it does override the global route setting. So for example, if in the global route setting for the corner radius, you have let's say 20 meters, which is the default corner radius. But in the LiDAR tools, you for instance, set it to, let's say 6 meters, which is the default for the LiDAR tools. This means that 6 meters will be used as the corner radius for the LiDAR tools. But if you have some other segments, then the global route parameter will be used unless it's waypoints where it is individual. So, and that's in general how it works. But I still think it's probably best if I show to you all of the new features in the software itself. So now it's time for the software demo. So let's move on over to GCS itself. So let me just arrange the windows here a bit. Hopefully it's fine. And so now let's move on into the software. So one of the first things that I want to show is, like I mentioned just now, is how do you connect from DJI Pilot 2 to UgCS. I don't have Pilot 2 in front of me, unfortunately, but I can show you at least how you can get the IP address here. So essentially, the process is the following. On DJI Pilot, you are able to connect to cloud platforms. There's a specific button there that says, cloud and then open platforms. And so there you are able to enter an IP address. So for the cloud server. So in this case, with UgCS, you can use it as a local cloud, so to say. So what this means is that simply you have both devices on the same network. So you have UgCS on the desktop, or laptop, I mean, and then you also have the Pilot 2 on the remote controller. And so then in UgCS, you can go here, click on the plus button, and then under this, you can select Connect from DJI Pilot 2. So then this window will open up. And so here you will see the IP address of your computer on the local network, which you can use, and the IP address and the port as well. And so this you can use to input in the Pilot 2. So then here also, of course, you have the instructions. So what to do. So first connect them both on the same network. Number 2, in the Pilot app, open cloud service connection page and select open platforms. And then in the URL field, you just simply enter this IP address exactly how it's shown here and then press on connect. Then after that, all of the routes will be already automatically visible in Pilot 2, plus you will see the drone's telemetry in UgCS here in real time. So that's about the connection from DJI Pilot 2 to UgCS. Again, if maybe something is still unclear or you have some questions, then of course, always you can contact us. So our contact email is support@ugcs.com. So yeah, that's about that. Then moving next, I just wanted to show you quickly about the M350 drone. So let's just go here into the menu, then let's go into profiles and the DJI M350. So here you can see, so now you have this drone profile available, M350 RTK, along with all the payloads from the DJI M300. And again, just a reminder, for this, you need to use the direct Pilot 2 connection. So that's about that. And I think maybe now we can look into using the Smart AGL terrain following mode. So here, as you can see, I have some hills. So let's maybe at first attempt to construct a normal mission with normal AGL, and then we can try to construct a mission already with Smart AGL. And also I'll explain to you how the algorithm works in certain cases. So for instance, now we can, let's say, first try to fly up this steep hill. So for that, we can then go ahead and create a new route. Click next here, and then let's select, for instance, the DJI M350 drone. So let's click on next again, and then let's click on OK. So for instance, we can try to create, let's say, a photogrammetry mission. So we have the camera selected as the DJI Zen Use H20 camera. And so then let's maybe go ahead and mark out the location. By the way, here I now already have the altitude mode set as Smart AGL. So now let's switch that to normal AGL. And now let's construct this mission here. Let's press enter to complete it. The direction angle we might need to move a bit. So let's move it like so. And let's see what will be the initial mission that will be constructed. Let's also maybe do the following. I'll just extend it a bit, just so it can go up the hill more fully, so to say. So let's maybe try like that. You can see, by the way, I have the AGL tolerance now set to 3 meters. So you can see what is how the mission has been constructed when using a normal AGL. So you can see also then as I'm kind of moving over waypoints so that the waypoints are more or less at the same altitude. So we have currently a GSD of 2 centimeters. And so you can see that these waypoints, they are set at 55 meter altitude, all of them. And then if we go here into parameters and then show elevation, so here we can now see the elevation profile for this route. By the way, now this window can also be resized. You can also kind of zoom in vertically in that. So yep, now we can move this window down here. So here you can see that basically when the drone is here on the ground, or more or less, I wouldn't like to call this flat surface, but I suppose you get what I mean. Then the altitude is held correctly. And here, even though it says that the altitude all through the route is 54, 58 meters, you can see that actually as the drone is flying here over the spot, so it does get too close to the cliff. So here, the distance to the terrain, when you're measuring the direct distance, it is for sure less than that. And this is something that you'll probably see on most flight planning softwares there. So this is a big problem people have to typically tackle when flying in very steep terrain. And so now we can take the same mission and then here where you see the altitude mode parameter. So this we can now change, and let's change it to the Smart AGL and let's see how it behaves. So you can see that now the route has been recalculated, and now let's take a look at that. So you can see that now, even as if we simply compare this visually, you can see that now there's a way higher distance. So way larger distance from the drone to the cliff wall. So yep, in this case, you can see that the Smart AGL algorithm, it measures the distance directly to the vertical cliff surface, thereby also allowing the drone to fly up the steep cliff without having to worry about the drone getting too close to that. Of course, assuming that the digital elevation model is accurate enough. But I think even with the default terrain elevation data we are using, so SRTM4, the drone in this case should be at a safe distance. If you're a bit more concerned, then you can even fly a bit slower just to be sure on the initial flight path to see how close the drone will be. At least that's what I would do when flying up steep cliff surfaces. But still, I think that with this, you should be quite a good distance away from the cliff there. Then I think also let's maybe try to construct another route, because I also want to show to you the behavior when the drone is flying over not such extreme cases, since we also have slightly changed the behavior of the side distances as well as the overshoots. You can kind of see it actually here as well, but maybe I'll just demonstrate also in a separate route. So now let's go ahead and create a new route. So then let's again select DJI M350 drone. And then let's go here. Then we can again, for instance, select the photogrammetry tool and then mark out a certain area. By the way, I see one question from Juan about, so what's the benefit of using UgCS for DJI or using the ability to connect directly from GCS to DJI Pilot 2? So with Pilot 2, what you actually get is that I think the pilots who are especially used to using the Pilot 2 and then they decide to switch to GCS, then firstly, it's a lot more easier for them to do because they still have the ability to, for instance, slightly change the mission in the Pilot 2. So for instance, if you need to change the location of the first waypoint, you can easily do that. All the drone settings, those are there. So also this means that in case DJI releases some updates, that then already you will have everything there in the Pilot 2. So this does make life a lot easier in that sense. Moreover, people who are using custom cameras, they also will be able to change all the settings. For instance, if you're using the phase 1 camera, we don't yet have the phase 1 profile, but I suspect we will also add it soon. Then also you can plan missions in GCS, fly for instance with phase 1 camera and have all the full integration with Pilot 2 when doing so. So in that sense, it is a lot easier. What is better on using GCS for DJI? And this comparison, I think, might be relevant to those of you using the M300 drone, because the M300, when used with the standard remote controller, this supports both ways. So the M300, you can either connect using UgCS for DJI app, or you can also connect it using DJI File 2. So the advantage of using UgCS for DJI app is that, for instance, all the commands such as upload routes, auto mode, and so on, these you can send from UgCS desktop. When you're using Pilot 2 integration, you need to initiate the auto mode or upload the mission from the Pilot 2 interface. Another thing is that currently video streaming, in case you have enterprise license and are streaming videos, this is for now for M300 only through UgCS for DJI app. So that's not available in the Pilot 2. But yeah, hope I managed to answer that question. Yep, so then let's move on to what I was showing to you before. So here you can see that we now have a photogram tree mission. And now let's take a look at how, basically what has been changed. So one of the things, this is by the way also now already with the Smart AGL. So one of the things we have changed is how these side distances work. So now actually the side distances, when you have to fly up a mountain, so in this case, you can see that the elevation goes up, so it increases. You can see that even on the side distances, the drone is following the terrain upwards as well. So this means that it is a lot safer, especially if, for instance, in the middle, you'd have a sharper peak. So in the middle of the side distance. So this means the drone will keep a safer altitude, even when moving on those side distances up the mountain. Similarly, also you can see here, so on the next path where the drone is also crossing between those two survey lines as well, it is moving up the hill here. However, in the cases when you are moving down the hill, this behavior will be slightly different. So I think that maybe to better illustrate that, I would have to change the direction angle around. Let's maybe try to maybe make it like so, just to maybe show the point a bit better. I'm just trying to find a good example of that. Because the behavior is also slightly different when you're flying up the hill versus also when you are flying down a hill. So now it's a bit of a struggle to get it to display just right, because everything has to be in the right position for to be able to correctly show this to you. Let's see what also we can change. Or maybe simply we can move this route to a new location or rotate it. So maybe let's try like that. If not, then we'll just need to move to a new location, I suppose. So anyways, in general, while I'm doing this, I can maybe also try to explain this a bit. So basically, if on the side distances, the drone has to move up a hill, so which means that the terrain gets closer, then the drone will follow the terrain upwards. However, if on the side distances, the terrain will get further away, so if the drone is flying downhill, then in those cases, the side distances will be planned parallel to the ground. So in those cases, the drone will not be changing the altitude. So let's maybe try like so. Replicating the first case when it's following the terrain is easier. Replicating the second one, where it is flying at a constant distance, that can be a bit harder. Okay, one example is here. So actually, you can see, so this movement here, this is a side distance. So this just because of the geometry of the route here. So this happens to be, a bit closer here. So in a diagonal line. So here you can see that by design, we made it so that in this case, the drone on the side distance, it doesn't actually move down. So since the terrain is moving downwards, then in this case, the drone simply flies straight, and then when safer, so then in this case, it already moves down to start the next survey line. So that's just one of the examples on how it works. Additionally, what we can do is we can add the overshoot a bit here, and then we can see what happens. So let's, for instance, try to add overshoot of 50 meters. So I believe with the overshoot also, we should get quite interesting results, but let's maybe try to move it a bit further down. So now let's see how it all works. Here, let's increase this more, for instance, 100. Okay, so I think here you can see quite a good example of how it can work in different situations. Here though, let's maybe extend this a bit. Okay, so one thing which you can see here is that also how the behavior has changed on the overshoots. So without the overshoots, the route would end somewhere around here. And so now you can see that when flying up the mountain, the overshoots also now follow the terrain. So this means that on the overshoot segments, the drone will also be following up the hill using Smart AGL terrain following. So that's one thing. And then the next is that when flying downhill and when you'll have the overshoot segments, in those cases, the overshoot segments will be set as they are here. So they will be set horizontal. So this means that instead of having the drone fly further down, in order to save battery, the drone will keep a basically horizontal plane, so to say, on the overshoot segments to save some battery and simply to make things easier and improve the efficiency when you are flying these types of routes. I'll just quickly maybe go through what are maybe what other questions we have. So can you use Smart AGL when you import a KML as waypoints? So Smart AGL currently it is not supported for waypoints. So to be able to use that, you would need to import. Although actually, Smart AGL it is supported for the following tools. So you have it for the photogrammetry, for area scan, lidar area, lidar corridor mapping, and lidar corridor. So currently for these 5 tools, you will have the Smart AGL. So you'll notice that for normal waypoints, you don't have the Smart AGL. But the question from Jacob is, so can you use Smart AGL when you import the KML file as waypoints? So answer is, when you import it as waypoints, you will not have that ability. However, when you import KML, you typically have one of 2 KML segments. So you either have a linear ring or you have, I believe it's called a linear line. And so essentially, when you import linear line, you also get the ability to import the route as a corridor. And so for corridor, you will have Smart AGL. So if you want to use that, you need to import that KML file as a corridor. So now I don't have any KML file which I can use now, but I hope that just by planning quickly some corridor mission, I can at least get the idea across. So for instance, let's do LiDAR corridor. You can see we have the Smart AGL terrain following function. And so now with this, let's just quickly plan some flight here. So let's do like so. I think now I have quite a large corridor width set. So now I'll change this to, let's say, just 50 meters. And yes, now you can see as well that we are using now the Smart AGL on the corridor. And so now you can see also that as the drone is flying up and down the hill, so now it is using Smart AGL terrain following function. So you can see that even when on the corridor scan, you have to fly up this cliff, even then the drone is keeping a constant distance to the ground. Now I'll just disable the IMU calibration, so that is not in the way. And then I want to show to you how this would look like on a normal AGL mission. So here you can see it on a normal one. This gets a bit too close for comfort, I would say, to this vertical slope here. So that's why, yeah, when you're, for instance, we can measure. So this waypoint altitude is about 30, 30, 30. So that's what we actually have set here. Typically, of course, you'd probably fly this type of mission at something like 50-meter altitude, but this doesn't really change the fact, because on Smart AGL, anyways, it will lift these points up. So here you can see this lifts, for instance, this point up to 63 meters AGL when measuring simply vertically, but it will still keep the same 30 meters to the vertical wall. So yeah, in short, to summarize, so yes, Smart AGL is also supported for corridors. So if you want the drone to follow the terrain, even on, for instance, one single flight line, then you can use the corridor missions. And in fact, what I like to do, maybe let's, for instance, let's say we, for instance, want to use, let's say we want to fly this area scan, right? So you might not always be able to take off from the same location where you have the area scan. So in those cases, you might have to fly over some terrain just to get to that location. And so many times I have heard the questions from drone pilots. So how can you do that? How can you fly just using waypoints? Because of course, if you just plan the flight with waypoints by design, it's like that we don't really add additional waypoints unless the altitude gets very dangerously low. However, you can actually fly to this location using Smart AGL with the corridor. So for that, I usually like to use the LiDAR corridor. And so now let's add one LiDAR corridor segment there. And so for instance, let's say that maybe we are located, for instance, somewhere here, right, at this house. And then if we want to fly using the corridor to this location, we can plan the corridor mission, press on enter. I will need to now change the order of that since it by default was added now at the end. So I'll just move the corridor to the very beginning. And also, oh, I think I might need to probably, let's see what's wrong here. Might need to, I think, yeah, just the width is what I need to adjust. Since now with the width of 15 meters, it flies there and back, and then it has to fly there. So yeah, we can now maybe change the corridor width something like 10. The flight height, I think we can set 50 meters easily. You can see the altitude mode we have as Smart AGL. And so now we can see that the corridor has been planned so that then when the drone is flying towards the area, it is using the Smart AGL algorithm. And in fact, you can also do this when you have to fly back. So for instance, if you have some mission where you have to fly over complex terrain to reach some starting position of another mission, then you can use the corridor in Smart AGL to fly there, fly the area scan mission, and then you can fly back. So now, for instance, I can select this photogrammetry tool, then we can do one other LiDAR corridor. And in fact, I can just put 2 points. So one at the beginning and one at the end, press on enter. And now let's see how it will be calculated. And so you can see it in both cases. So the flight is calculated correctly using the Smart AGL function. And so now if we go here into parameters and show elevation, so here you can see that's how it's being calculated and how overall it works. So you can see what's the distance the drone is keeping to the vertical cliff surfaces when it is flying to the location. So here, this is the first corridor, and this is the one where the drone is returning back. But I also actually now want to bring to your attention one currently limitation of Smart AGL, since I think it's also important to talk about. And so for that, let's maybe plan another mission here very quickly. So now let's create a new route. Again, let's maybe do for the M350 drone, and let's do a LiDAR area. So I'll just do something very simple. So we have altitude of 15 meters, and let's plan a flight like so. So this flight, at the beginning, let's plan it so that it's flying up the mountain surface. So let's maybe do it like so. Let's see what will be the result here. Okay, so here you can see this is the route, which we have now planned using Smart AGL. And so you can see what's the distance to the wall of the cliff when flying upwards. However, one of the limitations we have currently, which I hope will probably solve in the nearest future, is that Smart AGL does not currently calculate the corridor when sort of to the side of the flight lines. So it's only looking forwards. So this means that if you are flying along the surface of a mountain, so for instance, like so. So in these cases, when you have to scan the mountain surface like so, it does not calculate the distance to the mountain currently. So it's only looking forwards, which means that, let's say, if you have the flight height set to 50 meters and on these lines where the drone is flying, so exactly towards the direction of the flight, here the altitude will be calculated as it normally is now with Smart AGL. However, the lines are not moved. So I think in the future also we'll add some new thing to Smart AGL as an improvement to also be able to slightly move the flight lines in order to make it safer also when looking at the sides of the mountain when scanning it like so. But I just wanted to mention how it works currently. I think this is still quite a big improvement over AGL. So especially when flying up the mountains or flying up and over steep surfaces. But just one limitation, so you guys are aware, when you're flying along the slope, then in those cases, it still does not keep the distance because it's kind of that by design. Otherwise, we would probably have to move all of the flight lines a bit further, which again, we're just looking at all the scenarios here, which in some cases can create a bit more danger. So for now, just so you're aware of how the algorithm fully works. And let's quickly look at some questions. So yeah, thank you for hope that you liked. I see that you liked what I'm showing and that you like the algorithm. So, oh yeah, the AGL tolerance. So yeah, the AGL tolerance parameter is still there. And so now we can also actually take a look at how it would work. So we can go here. So you can see currently AGL tolerance is set to 3 meters, and you can observe how many waypoints are here. And then let's see what happens when we, for instance, we can even actually open up the elevation profile here. So you can see we have 36 waypoints, and now we can change the AGL tolerance to 1. And so now you can see we have 55 waypoints. So to answer your question, yes. So the AGL tolerance, it does still work in the same way. So if you want to increase the resolution at which the drone is following the terrain, then you can decrease the AGL tolerance, or vice versa. If you want to decrease the amount of waypoints and not have a GCS insert that many waypoints into the route, or at least not insert them as often, you can increase the AGL tolerance parameter. So then, yeah, I hope I answered that question. And yeah, next, so there's a question also about GCS Pro and Smart AGL. So then just to clarify that, so Smart AGL, it is available for flight planning in all licenses. However, Smart AGL, it is limited to expert and enterprise licenses. So if you have currently GCS Pro license, you will see the Smart AGL here, and you will be able to plan the missions. Just so you'll be able to basically experiment with it, see how it works, see how it performs in different situations. However, you won't be able to upload routes with Smart AGL to your drone if you have a Pro license. So in those cases, you can upgrade your license to GCS Expert license, and then you will have full access to Smart AGL. So yeah, in short, so it is supported in Pro license for flight planning, but for route export or for route upload to drones, you need to have at least expert license. So yeah, I hope that I answered this question. So again, will Smart AGL, can the drone return? Okay, I'm trying to read the question correctly. Can the drone avoid obstacles on the route? So Smart AGL, it does not move the drone to the side. So it only moves the drone up and down. But in case you have some obstacles, such as, for instance, a building in front of you, then the Smart AGL should actually move the drone around the building. And actually, what we can try kind of while we are here, although actually, maybe it might just take a bit too much time, because let's see, we're already at 42 minutes and I still won't be able to answer some other questions. But in general, yes. So to answer your questions, so GCS does also take into account obstacles. It should also take into account no-fly zones when flying with Smart AGL. So whenever it has to fly over something, Smart AGL will be used when selected here in the flight planning tool. Okay, so then let's see what else. What other questions I can answer now? But okay, I think let's do the following. So now I have one more topic that I want to cover here, and then we can move on to the questions and answers. Otherwise, I know that sometimes I get already too much in answering questions, and I forget I still have one more topic I need to cover. So now the final topic here is the corner radius. So now let's move into that. For showing it, I will plan another mission here for our beloved M350 drone. And so in this case, I will use a normal photogrammetry. Here, it doesn't actually matter if we're using Smart AGL or not, but let's maybe go to some area where the terrain is a bit more normal, a bit more what we're used to. So now let's plan flight like so. Let's change the direction angle here a bit. And okay, so here we have our photogrammetry route. And you can see, so currently we are using the stop and turn type here. We have some overshoot as well. The overshoot, actually, I believe we can remove. That's not necessary for this. So this is how the routes have looked like normally in UgCS up until the newest version. So now, one of the new parameters you have, if you go here into the root parameters, here you now have the ability to set the corner radius. So now by default, the corner radius is set to 20 meters. So this is used when you are flying with adaptive bank turn type. So now if you go ahead and change from stop and turn to adaptive bank turn, so now you will see that the root now actually has this curvature. So now it shows how will the drone fly through the flight line. So how will it corner exactly? So now this is all also visualized. So this is now for all flight planning tools when you are using adaptive bank turn. So you will now be able to see the corner radius and how it will corner. For instance, if we now go back and then change the corner radius back to, let's say, 6 meters, now you'll see that the corners will be a bit more squared off. And similarly, if you now go and change it to, let's say, something like 30 meters, then you'll also see that now the corner radius will be even more curved than it was with 20 for obvious reasons. And one more thing is that now, even when you're using individual waypoints, you are now able to set the corner radius even for individual waypoints. So currently these are still using stop and turn type. So what I can do now is I can select this waypoint and then just hold the shift button and then select this one. So now all three of these are selected. And now what we can do is we can change the turn type from stop and turn to adaptive bank turn. And then you'll see how the flight line now also curves when you are using even just normal waypoints. So now let's maybe put a few more here. Let's wait for the route to be calculated. And yes, now you can see we have a nice smooth curved line here. And now what we can do is, for instance, if for some waypoint you want to have a different corner radius than the one set in the route, what you can do is you can go here and, for instance, change this corner radius to 6. So this means that now for all others, you will have corner radius of what's set in the route, which is 30. And that for this specific waypoint, you will have a lower corner radius. So here you will have 6 meter corner radius. So I hope that this is clear. The corner radius is available for DJI drones, for both older and newer. So any DJI drone which you can connect to UgCS, for that you have also access to corner radius. Same goes for the Smart AGL. So this is also supported. Smart AGL is actually supported for all drones and UgCS. So even for non-DJI drones, Smart AGL is also available for flight planning. So yep, that was then about the corner radius. And I think that now we can probably go into the Q&A. And just before that, I wanted to just mention about the Smart AGL. So if you currently have a UgCS Pro license and you would like to upgrade from Pro to Expert to get access to the Smart AGL as well as the LiDAR toolset, then you can head on over to ugcs.com/upgrade, or you can just scan this QR code, and then you can purchase the upgrade on our website from Pro license to Expert. And what's also cool, by the way, is if you, for instance, have an outdated support period, maybe it has ended, or maybe you know it will expire soon. So if you do the license upgrade, this also will renew your support period. So this means that you won't have to pay for the support period. So when you do the upgrade, you also get support period for 1 full year. So yeah, if you want to get access to Smart AGL, this would be the way to go if you have a Pro license and want to upgrade. But yeah, so I think that now I'll just leave this on the screen for now, and let's take a look at what questions we have and what can I now answer live. So the first question I now saw is any updates on adaptive turns and the LiDAR toolkit on PX4. This is very close to actually being already in the development in the sprint. So I expect that this could be coming. Don't want to get your hopes up too much, but maybe even in the next month we could release the LiDAR tools for PX4 drones. So it's very, very close to being ready and very, very close to being released. So yeah, stay tuned, and soon LiDAR tools for PX4 drones will be coming. And by the way, speaking of PX4 drones, as many of you may know, so one of the latest drones we actually added to UgCS as a supported drone is the FreeFly Astro drone. So now from FreeFly, we are supporting the Alta X as well as the Astro drone. So then this question, I believe I answered. Then let's see. So yeah, the question about the M350 drone support of the Laser Falcon and True Terrain following system. So yeah, here, this is currently in development. So currently the M350 drone is supported in UgCS, but is not supported yet for the integrated systems and the sensors which we provide. But you can expect that in the near future, also the support will be rolled out. So also the M350 will support SkyHub as well as different sensors. So now let's see. What else? Oh yeah, so for those of you who need access to Smart AGL and who come from search and rescue background, also please get in touch with us. I know that on search and rescue teams, oftentimes there's obviously different budget than for others. So, we're willing to come to some compromises and also help you guys out. So if you come from search and rescue background and need the Smart AGL tool for being able to help find missing persons, then please reach out to us, and then let's discuss and let's see what we can do, and how can we help you with being able to get that. So then let's see what else. But other new improvements which you can expect. So we don't keep a public roadmap of new improvements, but yeah, one of the mention is that quite soon I hope you can expect also to see LiDAR tools available for other drones. So even non-DJI drones will have access to LiDAR tools. That's one thing we can share, which we are working on. So then yes, so the Smart AGL, it also does account for buildings. So when you have to fly over buildings, the Smart AGL will also work and will be able to bring the drone above the building while keeping a constant distance to it. So if you have a building model imported, then also this will work. I have not, to be honest, I have not tested it myself with no-fly zones. If you'd like, then when I answer a few questions, we can test it out. I think it should also be possible for no-fly zones when you have it configured so that it flies above the no-fly zone, which no-fly zones, by the way, can also oftentimes be used to simulate some objects, or to simply, when you don't have an exact model of an object on the map, but when you, for instance, know where the object is, you can also use it for the flight planning. So for what angle is the Smart AGL valid? That's more internal thing for the algorithm itself. There's no option to adjust the angle currently, but we are thinking about maybe adding something like that. So when you're flying with Smart AGL, you can also adjust at what angle is the drone flying, up or down. So if you're interested in that, then also this might be coming. Another thing, about the 3D tiles. So Juan, also I see this question from you about Google 3D tiles. So we are looking in that. With 3D tiles, there's a lot of good things, but also there are some technical limitations associated with them. I will not get into too much detail with that. But so we are looking into possibility of having something like that, but for now it's still in the investigation stage. And so let's see what other questions we have. But I believe, most of them I have answered. I see another question from Kyla is about so having a camera angle perpendicular to the ground rather than a fixed angle. Also very useful question, feature suggestion. We have been thinking about that actually. By the way, Kyle, one thing that's maybe you can also write in the Q&A here or in the chat or wherever is more easiest for you. One thing that we have been also thinking about is so if we implement the ability to also plan the flights, for instance, when you fly with AGL, Smart AGL, I mean, up certain slopes, and then the camera is adjusting. Should also a camera have some tilt or some roll, or basically only the tilt? For now, I think that having the tilt only would work. So, we could, for instance, understand, so what should be the plane, approximate plane angle on each point, and then implement that. And I think also, of course, will be quite useful, because when you're mapping out these kinds of surfaces, in many cases, like a fixed camera angle just doesn't cut it, and you need the drone to be able to, keep the camera perpendicular to whichever surface you are scanning. So that's something also we are looking into adding, and that might be coming in future versions. So the more suggestions we get about that, the more people we see are interested in having such new features, then the more likely they are to get into development and be added. Also, yeah, Jacob, by the way, I see your suggestion about the mission completion, some ETA. And that's also something that has been widely requested, having some timer for how long will the mission take. And so you can also expect that in some of the future versions, this feature might be coming. But yeah, I think that now we are already a bit almost out of time. But yep, I think that if you have any more questions, I think for now, let's maybe keep this going for like some 5 more minutes, just because in the meantime, while maybe are adding some new questions there, I can try to see how it will perform in case of some buildings here. So we now have the Smart AGL mode. And then, so let me make this full screen so it's nice. So here, let's change this just a bit. I think the waypoints I no longer need, so these I can just remove from here. So now let's wait for the route to be calculated. And now what we can do is we can add a no-fly zone. So for instance, we can add a cone no-fly zone. For that, let's have it start from the ground and be of a limited height. So the height, for instance, we can adjust to, let's say, 10 meters. And then the, let's maybe even do more. Firstly, the radius, I think, let's change the base radius to something like 50 meters. Top radius, we could do the same for the no-fly zone. And the height, let's also maybe change this to something like 40 meters. Let's see how it behaves. But again, I have not tested the Smart AGL with no-fly zones, so I am also just curious on how it would work. I think we need to set this higher, so let's maybe try something like 80 meters. Okay, so actually it does increase the flight height, but it seems that, yeah, it does not keep the distance to the no-fly zone. So that's one limitation currently. So yeah, here you can actually see how it performs around no-fly zones. However, I would also actually need to test this with the building model because the behavior there might be a bit different, because at least I remember seeing one screenshot where it did also actually keep the distance around like near the building. So this one I will need to test. So no-fly zone behavior also might be a bit different than when the drone's flying around buildings. But yeah, at least with no-fly zones now, it is a bit more clear. So yep, let's take a look at what more suggestions you have. So suggestions, questions, anything like that. So let's see. Well, I think quite a lot of them were simply from different, I think a lot of you are interested in what new features we're bringing to the table. And about these, I think I already mentioned quite a lot. And yeah, so then let's see where I have my presentation window. Yeah. So then I think we can probably then end the webinar. So it's almost exactly 1 hour from the start. So very, very punctual this time, I think. So yeah, I just want to say thank you to everybody for coming and listening to the webinar. In case you want to see the webinar again, or maybe you missed some parts, then the recording will be sent to you afterwards. So yeah, thank you for watching. Thank you for asking your questions and interacting. It was quite interesting, I think. And then, yeah, let's keep in touch and see you in the next one.